We're about to dive into one of the most important documents of the entire 20th century. But what's so wild is that the guy who wrote it had no idea he was inventing the future. Nope, he was just trying to solve a really, really hard math problem.
So let me ask you a question. If I said, show me the original blueprint for your smartphone, what would pop into your head? Probably some super complex circuit diagram, right? Or maybe a patent from a huge tech company.
Well, believe it or not, the answer is this. A dense academic paper from 1936. Yeah, it's called On Computable Numbers with an Application to the Entscheidungsproblem. This is it. This is where the modern computer was born. Not in some fancy lab, but as an idea on paper from the mind of a 24-year-old Alan Turing. Now, to really get why this paper changed everything, we have to go back and understand the absolutely massive problem Turing was trying to solve. This was a question that had the greatest mathematicians of the time completely stumped. It was called the Entscheidungsproblem, German for the decision problem. And the challenge was this. Could you, in theory, create one single perfect algorithm, a universal method, that you could feed any mathematical statement to, and it would just spit out a simple, yes, it's provable, or no, it's not. It was basically a hunt for the ultimate mathematical truth machine. But Turing, he had a hunch. He didn't think any such process could exist. So his goal wasn't to find the algorithm, it was to prove that, in his own words, no general process like that could ever exist. But to do that, he had to do something kind of brilliant first. He had to define what a process even means. And this, right here, is where the genius of it all kicks in. Turing realized, hey, before you can prove what some general process can't do, you first have to nail down what a process, or a computation, is. Like, what are the absolute rock-bottom fundamental steps of any calculation? To figure this out, he used this really simple but powerful analogy. He just imagined a person, a human computer, let's say, sitting there carefully working through a math problem. And then he just broke down what that person was doing into the simplest possible parts for a hypothetical machine. He figured this human computer would need a few things. First, some paper to write on. Let's call it a tape, an infinite strip of it. Second, their eyes would act as a scanner, looking at just one square at a time. Third, they'd have a limited number of mental states, what he called M configurations. Like remembering a 1 or knowing you're on step 3. And finally, and most importantly, a simple set of instructions to follow, with no ambiguity. And this is the really important part. This conceptual machine is totally deterministic. He called it an automatic machine. If it's in a certain state and it sees a certain symbol, its next move is already decided. There's no intuition, no guesswork. It just follows the rules, pure and simple. And check this out. Here's a real example of how it works. This little table of instructions, it's just 4 simple rules, tells the machine how to generate an infinite sequence of 0, 1, 0, 1 forever. Like if the machine is in state B and sees a blank, it prints a 0 and moves to state C. If it's in state C and sees a blank, it prints a 1, and so on. It's a simple, predictable computing machine. But, and this is a big but, each machine could only do one specific thing. This is where Turing takes the next giant leap. He goes from this idea of a one-trick pony machine to the idea of a single machine that could do, well, any task. So the question became, okay, instead of building thousands of different machines for thousands of different problems, could you build just one? One master machine that could pretend to be, or simulate, any other machine you could dream up. And then, in the paper, he just drops one of the most important sentences ever written in the history of technology. He says, it is possible to invent a single machine which can be used to compute any computable sequence. Boom. That's it. That's the Universal Turing Machine, the theoretical idea behind every single software-run computer ever built. So how on earth would this master machine work? Well, the key idea was that the instructions for any specific machine, like that little 0101 machine we saw, could be translated into a unique code. Basically, a really long string of numbers that Turing called its description number. You can think of it as a digital instruction manual. This description number, this is the magic ingredient. You just feed this number to the universal machine on its tape, and that number tells the machine how to behave. That number is software. The instructions are no longer baked into the hardware.
They're just data. The entire concept of a stored program computer, it was born right there in that idea. Okay, so now that he's basically invented the theoretical computer, Turing can finally circle back and answer that original question, the one that started this whole thing. And by using the logic of his very own universal machine, he proved that no general process for solving all of math could ever exist. The decision problem was and still is unsolvable. So he'd done it, he achieved his goal, but in the process, he had done something infinitely more important. I mean, just stop and think about the incredible irony here for a second. His mission was to solve a deep problem about the limits of what could be calculated. But the result? He accidentally gave the world the blueprint for a machine with seemingly limitless potential. The byproduct of his work completely blew the original goal out of the water. So the legacy of this single paper is just staggering. It gave us the very definition of what computation is. It formalized it with the Turing machine. It handed us the blueprint for the universal software-run computer. And yeah, it also proved that some problems are just fundamentally unsolvable by any machine ever. It really leaves you with this fascinating final thought. Did Turing set out to discover the absolute limits of mathematical proof? Or did he, by complete accident, end up discovering the ultimate potential of the machine? It kind of seems like the answer is